Hey, my name is Manish Gupta. In this video, I'm going to talk about DeltaLM, which is an encoder decoder pre-trained model for language generation and translation. And it works by augmenting pre-trained multilingual encoders. So let's get started. So what is DeltaLM, right? Well, DeltaLM is a pre-trained multilingual model, as we discussed, and there have been, it's an encoder decoder kind of architecture, right? So there have been several encoder decoder pre-trained NLG architectures that have been proposed in the past, including T5, BART, and MAS, and multilingual versions like MT5 and mBART. In fact, thinking from a pre-trained multilingual perspective, there have been encoders as well, like mBART, XLM, XLMR, InfoXLM, very powerful encoders which work in a multilingual perspective. DeltaLM is a pre-trained multilingual encoder decoder model. And well, you use pre-training here so that you can inherit the cross-lingual transferability of the pre-trained encoder. So the way it is trained is that, as you see here, it's an encoder decoder framework. And then for both the encoder as well as the decoder, you sort of use an existing pre-trained multilingual encoder for initialization. In fact, DeltaLM specifically uses InfoXLM as the pre-trained multilingual encoder just to initialize both the encoder and the decoder, right? And then further, after you've initialized, you further tune it using both monolingual and bilingual data, which we'll talk about more in detail, right? So in DeltaLM, as we discussed, you initialize both the encoder and the decoder with the pre-trained InfoXLM-base encoder, which is a 12-layer encoder, right? So it's a 12 plus 12 layer architecture in general. And the pre-training is done in a self-supervised way with these two losses, corruption and translation span corruption tasks, which have been which sort of make use of this bilingual and monolingual data. Okay. So that's basically a one slide overview of what is DeltaLM. The code and models are sort of available there, so you can actually take the model checkpoints from right from there. Okay. Now there's a slight tweak. So in the decoder side, you of course initialize it using the InfoXLM base model. However, the architecture of the decoder is slightly different, right? So here is a vanilla decoder from Transformer. You have a vanilla Transformer decoder. You have a self-attention sublayer. You have a cross-attention sublayer, encoder decoder attention sublayer, right? And then a feed-forward sublayer. So and then you have n of those. So in a standard transformer, you have 6 of those vanilla decoders. However, in DeltaLM, they basically made a few changes so that the decoder also has a more consistent structure with the encoder. And you want this consistency in structure so that you can use an existing InfoXLM encoder for initializing the decoder part. Okay. So the changes that they've made in this decoder, they call it interleaved decoder, is that they interleave feed-forward layers with attention modules. So you see there is feed-forward layers, and then there are these attention modules. And then every other self-attention module is sort of replaced by a cross-attention module. So what you have is a self-attention feed-forwards, cross-attention, and then feed-forward. And then they've, of course, also reduced the number of such decoder layers to two-third of the overall number of decoder layers one would usually have in a vanilla transformer model. Okay. So how do they initialize this decoder? How is it initialized? So well, it's initialized in these forms. So the self-attention and the bottom feed-forward sublayer that you see are initialized with the odd layers of InfoXLM. And the cross-attention and the top feed-forward layer are initialized with the corresponding even layers. So that's how you initialize this interleaving kind of thing sort of implies that we use the pre-trained weights from InfoXLM rather than actually initializing any of these sublayers in DeltaLM with random initialization. Yeah. So that's that. Now, how do you pre-train? So initialization is good. You have monolingual and bilingual data. How do you pre-train DeltaLM, right? So you pre-train using these two different loss functions called as span corruption task and translation span corruption task. So the tasks are pretty simple. The main idea behind these two tasks is to make best use of existing large-scale monolingual and bilingual data. Okay. So in the span corruption task, the idea follows very strictly from MT5 the way they do. So you basically take an original sentence as input, right? And then what you do is not give the original sentence, but give a masked sentence as input. So you have masked out a few spans. Remember, they are not subwords to be masked; they are full spans to be masked, right? And then at the output, you of course expect that the model should be able to guess the values for those spans. For example, in this case, rather than mask one, it should be able to predict for year, and mask two, it should be able to predict last week, right? So the probability of corrupted tokens is 15%, similar to BERT, but average length of those spans is 3 tokens. So rather than just 1 token, you have average length about 3 tokens. The translation span corruption task is a sort of an extension of the span corruption task, and it follows the way it was done in MT6. You basically take two sentences which are translations of each other, so English and Chinese. And the idea is to, of course, be able to recover those spans. Probability of corrupted tokens is 0.5. So you corrupt a whole bunch of tokens so as to make it more efficient in terms of training with respect to the number of samples that you pass in, right? And the average length of corrupted spans remains 3, right? So that's that. To do this, a lot of pre-training data was used, about 6 TB of world data, which is a combination of CC100, CCNet, Wikipedia, covering 100 languages. So very rigorous pre-training in that sense, right? It also contains 88 GB of bilingual data from CC aligned and Opus Corpus, which is about 77, which has 77 languages. So pretty large monolingual as well as bilingual data has been leveraged so as to pre-train DeltaLM. Yeah. Now, how does DeltaLM perform across various tasks? Let's talk about that. So here is an example of multilingual language generation. Okay, so you're trying to do language generation, and therefore there are two tasks considered here. One is abstractive text summarization. So not extractive, but abstractive text summarization, and the other is question generation, right? So for abstractive text summarization, they use the French X-Giga corpus, where which basically contains the first. It's a corpus from news articles, and the idea is that you take the first sentence and the headline of the article as your summary, and the entire document is basically your document, right? The entire article is the document. The dataset is pretty huge, so it has about 500K train pairs, train pairs, 5K and 5K, validation and test pairs. For question generation, the task is exactly this. You are given an answer and a passage, and you have to basically predict a question which can help come up with that answer. Okay. For this, they use Chinese XCG data, Chinese cross-lingual question generation data, which has been constructed from another data set called as WebQA. Okay. It is also pretty large. It has 135K training samples and 5K and 3K validation and test samples. So as you see, here are the results, right? What do you see? So it has been compared with the two models, XLM and XNLG, right? Now, these are also other pre-trained multilingual, encoder decoder models previously proposed about 2 years back. And what you see is that DeltaLM actually gives you good results on both the data sets, right? So the results have been evaluated using metrics like Blue, Meteor, and RuGel, right? And across all of those metrics, you see that DeltaLM wins. Not just that it wins, but also it wins with a smaller size. You see the size of DeltaLM model just 360 million parameters, while the other two are way larger. Yeah. Now here are results for another kind of task. In this time, cross-lingual language generation. Remember, this was not cross-lingual. If the input was Chinese, the output was Chinese. The input was French, the output was French, and so on. So cross-lingual language generation, the particular task is machine translation. It makes use of WMT10 dataset, which contains parallel translated data across 10 different languages. So French, Czech, German, Finnish, Latvian, Estonian, Romanian, Hindi, Turkish, and Gujarati. Okay. So as you see across all of these languages, there are results which are presented. The top table is for other language to English. The bottom table is for English to other language, right? You see various methods that are being compared. There's bilingual NMT. This is basically for every pair of languages, you learn a different model. Okay. And then there's multilingual NMT. There is mBART. There are also these recently proposed models M2M, right? M2M 100. So what you observe is that DeltaLM has 360 million parameters. Compare it with like say 1.2 billion parameters for M2M 100, right? The larger model. Or compare it with mBART, which is twice the size almost, right? But then what you see is that on average, DeltaLM gives you better accuracies compared to any other models, right? Any other models in both the directions, from English to other language or other languages to English. So that's that. And interestingly, well, for some languages, maybe DeltaLM is not that great, right? But maybe there's some model which can for a particular language, it may lead to better accuracies. For example, this one slightly, right? But then on average, of course, DeltaLM performs way better compared to any of those baseline models. The yet another cross-lingual language generation task is abstractive summarization. So essentially, the input, let's say, is in English and the output is in Russian, right? So or rather, the input is Russian and the output is English. Well, they consider those directions. So they have 4 languages: Spanish, Russian, Vietnamese, and Turkish. And the idea is to generate abstractive summaries in English. They use the Wikilingual dataset, which has 770,000 article summary pairs, and this dataset has been obtained from the website called WikiHow. Right. Um, so they compare with several existing pre-trained models: mBART, MT5 small, MT5 base, pre-trained, and then fine-tuned on this train set, right? Of course. And they compare with so many other models, and they also compare with MT5 large and extra large models. And what you observe is that DeltaLM actually achieves competitive score with MT5 large, right? If you actually look at averages, right, across all the 4 languages, you observe that 35.3. So, it's sort of pretty competitive with respect to MT5 large. Of course, it's a little worse than MT5 XL, but hey, it's competitive with respect to MT5 large, which has, if you notice, which has like 3 times the number of parameters, right? So DeltaLM is a pretty promising model, right? A small model gives you better accuracies. Okay. Let me also talk about yet another cross-lingual language generation thing, cross-lingual data to text generation. And in this task, the idea is you're given several triplets, more like subject to object kind of stuff, right? Facts. And you have to come up with a natural language description for that. Right? They use the WebNLG dataset for it, and it's a bilingual dataset of parallel DBpedia triplet sets and short text. It is English versus English-Russian. Okay. So now this one actually contains about 17,000 triplet sets, 17,000 facts, and 45K short texts in English, as well as 7K triplet sets and 19K triplet sets in Russian. Okay. So now again, they compare with those standard baselines, and they observe that yes, DeltaLM gives you way better results compared to any of those baselines. This time it actually defeats even MT5XL, leading to the best state of the art model on this WebNLG data with just 360 million parameters. Okay. Lastly, let me talk about the zero-shot capability of DeltaLM. Zero-shot cross-lingual abstractive text summarization using DeltaLM. Well, here they use the XGiga dataset and they train on 50K English to English text summary train set and evaluate it on French and Chinese, right? So that's why it's called zero-shot cross-lingual, right? So and so the idea is that if you basically take the pre-trained DeltaLM model and you essentially fine-tune it on summarization data, it leads to fine-tuning. This fine-tuning sort of leads to accidental translation errors in a language which is unseen, and therefore at fine-tuning time they actually mix the pre-training tasks into the fine-tuning stage. So during fine-tuning, half of the time you're actually fine-tuning based on these downstream tasks of summarization, while the remaining half you're essentially using the same objective as the pre-training task, span corruption and translation span corruption. Okay. So here the XLM, of course, is essentially fine-tuning XLM on English data and test on Chinese and French test sets. So it's basically again zero-shot in nature. But this one, XLM-MT, is basically you translate the French sentences into English with Google Translator before actually summarizing with XLM, and translate the predictions back to French sentences. So that's how it is done. So it's more like a translate and then summarize and then translate kind of a baseline. So it's a pretty strong baseline from that perspective. But the interesting part about DeltaLM is that, well, it significantly outperforms all of those baselines across both the data sets, the XGiga French as well as XGiga Chinese, and by a significant margin at that, right? With the much smaller of a model, and across all metrics. So Rouge 1, Rouge 2, Rouge L. Okay. So let me summarize this video. In this video, I talked about DeltaLM, which is a powerful pre-trained multilingual encoder decoder model for both language generation as well as translation. Now, we also talked, in fact, about other tasks like summarization, question generation, or even fact to text and so on. Right. So DeltaLM initializes the encoder and decoder with InfoXLM-base. It also uses span corruption and translation span corruption while doing pre-training, so as to make robust use of large-scale monolingual and multilingual, datasets, monolingual and bilingual datasets, right? It actually performs better than MT5 and mBART on various language generation and translation benchmark datasets while being smaller in size. Okay. So hope you liked the video. Thank you for watching. Connect with me on LinkedIn or look at my research on my homepage. Thank you.